Good evening, everyone. This is June 2016, Unit 4 of IAL projects. In the first question, the diagram shows a track from an event at point P in a bubble chamber. There is a uniform magnetic field directed into the page. So, magnetic field is into the page, process representing into. Which of the following is the reason why the track shown cannot represent the production of proton and antiproton with equal kinetic energy? So if proton and antiprotons are produced particle and antiparticle, they will follow the different trajectory, opposite trajectory, and because they have the same kinetic energy, so the curvature of the path should be same as well. The option which shows that it cannot represent the production of proton and antiproton in this event, that the tracks have different curvature. As the tracks have different curvature, it shows the particles which are produced here having different kinetic energies. For question 2, the table compares the mass and the charge of electron with the mass and charge of positron. So positron is antiparticle of electron. So particle and antiparticle, they will have the same mass, but they will have different charge. So the mass will be equal, but the charge will be opposite. So B is the right answer. For question 3, which of the following is a correct statement about the uniform electric field? So uniform electric field, we have the formula E is equals to F over Q. So this field strength is same at all the points, that's true. So the force is same throughout the region, or the field strength is same throughout the region. That's why A is the right answer. What about option B? The field strength is same in all directions. So it is not saying the field strength is not same in all the directions. For example, if you have a uniform electric field between the two electrodes or the capacitor, between the plates you have a uniform electric field, but on the left hand side of a positive plate or on the right hand side of a negative plate, you will not have a uniform electric field. That's why option B is not correct. The field produces no force on stationary charged particle. There will be a force, and it will be a constant force. The force on the charged particle is perpendicular to the field. So force, it's always the direction of the force is according to the force experienced by a test positive charge. So if we place a positive charge, as electric field is from positive to negative, the positive charge will move towards right hand side. In question 4, in an electron gun, electrons are released from a heated filament. What is this process called? When this is called a thermionic emission, because excitation is when the electron jumps from lower shell to higher shell. We call that as excitation. Ionization means when we completely remove the electron from the atom. We call ionization. Photoelectric emission, when the light in the form of packet or photon falls on the metal surface, so these electrons at the surface absorb energy and release from the metal. In question 5, the diagram shows two horizontal plates separated by distance d. There is a potential V across the plate and oil drop with a charge Q is held stationary between the plates. Which of the following give the mass? So here the electric field is equals to the gravitational field or the weight. So we can say weight is equals to electric force and weight is equals to mg, and electric force E is equals to F over Q, so F is equals to E into Q, where Q is a charge. So mg and V, between the parallel plates, V is equals to ED. So E is equals to V divided by D. So we can write V divided by D, and that is multiplied by Q. Or we can also say it will be VQ divided by D. If we need M, so that M is equals to VQ divided by d, the distance between the plate, and g is the gravitational field strength. So it matches with option B. In question 6, which of the following is an equivalent unit to Tesla? Tesla is a unit of magnetic flux, magnetic field strength, or magnetic flux density. So we have the formula F is equals to BIL, or F divided by IL is equals to B. So F is the Newton, unit is Newton, F is the force, unit is Newton, I is the current, unit is ampere, and length SI unit is meter. So it will be Newton, ampere minus 1 and meter minus 1. That is equivalent to Tesla. So B is the right answer, or Weber per meter square. The magnetic field of flux density 4 exponent minus 3 passes through a coil of wire at an angle of 55 to the plane of the coil. The coil has an area of 2.5 exponent minus 3 meters square. Calculate the magnetic flux through the coil. So we always required a perpendicular component to the surface. So this angle is 55. The one which is with an angle, if this is B, the one which is with an angle B cos theta, and perpendicular to the surface is B sine theta. So B sine 55, the perpendicular component of the magnetic field to the surface, we need magnetic flux. So flux is equals to, or phi is equals to B dot A. And because we are taking a perpendicular component to the surface, so it will be B sine 55 into A. The value of the B, the magnetic field strength is given, it is 4 exponent minus 3 multiplied by sine 55 into the area is 2.5 exponent minus 3. So when we substitute the value, that will come out as 8.2 into 10 to the power minus 6. So it matches with option B. A proton accelerates in an electric field and gains kinetic energy, giving it a change in momentum delta P. An alpha particle accelerates in the same electric field and gains the same kinetic energy. The magnitude of the change in momentum. So we know kinetic energy, which is half mv square, and how we can relate kinetic energy with momentum. If we multiply this equation by m, so we can write that kinetic energy is equals to m square v square by 2, or kinetic energy is equals to momentum squared by 2m. Further simplify, so it will be kinetic energy multiplied by 2m in under root is equals to momentum. So kinetic energy does not change. What is the relation between momentum and mass? So it is proportional with under root. So when we compare the mass of the proton with mass of the alpha particle is having 2 proton, 2 neutrons. So its mass is 4 times compared to that of proton. So what is the change in momentum if the mass is 4 times, because it is under root, so it will become under root 4m, which is equal to 2m under root. So if your original momentum was delta p, as you can see, if this is multiplied by 4, there is a square root, so this will be multiplied by 2, so the momentum will be w. So the right answer is B. Question 9. A 4 microfarad capacitor discharges through a 563 kilo ohm resistor. What is the time constant? Time constant, or RC, the product of R and C. So this is 560 into 10 to the power 3, and the capacitance is 4 into 10 to the power minus 6, as it is microfarad. So when we multiply these two, it will come out as 2.2 second, because the time constant is R into C. A proton enters a magnetic field. It has a velocity v perpendicular to the magnetic field. The diagram shows the path taken by a proton. An alpha particle enters the magnetic field at the same point as proton, also with the same velocity, at which point A, B, C, or D is the alpha particle most likely to leave the magnetic field. So alpha particle is having a greater mass. So as it is having a greater mass, it will have less deflection. So D shows that no deflection. C shows compared to B, C shows it is less deflection. So massive particle or a heavy particle will deflect less in a magnetic field as compared to a lighter particle, as a magnetic force is given by F is equals to BQ V. So the correct answer is C for question 10. So this was Unit 4 of IAL Physics from June 2016.